Okay, so the next one says, fully expand p plus q to the power of 5. So that's all it says. So p plus q to the power of 5, 4 marks for that. Fully expand this time. So as you can imagine, that means we're going to have to use the entire row here. Okay, it doesn't say the first 2 terms, doesn't say the first 3 terms, ascending powers of x, doesn't say anything like that. It says fully expand. Okay, so that's why it's 4 marks. But that's all you have to do for this one. So you just expand. So just be careful. Okay, there is no negative here, so it should make it a bit more straightforward. Just remember you're descending for the first one, first term, and ascending for the second term. So what would that look like? So we've got the fifth term over here. So 1, 5, 10, 10, 5, 1. So the first term will be 1. P. So we've got descend. So you start. If you're going to be descending, you start with the highest possible power, which in this case is 5, multiplied by q. Ascending, lowest possible power would be 0. 5 plus 0 is 5, that makes sense. And then just keep going. So we've got 5 times p again, descending, so it's going to be 4. Ascending, q is going to be 1. Plus, next one, 10. Descending. Keep going. 10, 10 again. Descending. Ascending. 5. P would be 1. Q would be 4. That's always a check, remember. Yeah, you can always add the powers and you should get back to 5. 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2, 2 plus 3, 1 plus 4, all give you 5. So you know you're doing it right. And then the last part is the coefficient of 1. P will now be 0, descending, 2, 1, 0. Q should be up at 5. And these have now reversed. P, 5, Q, 0, P, 0, Q, 5. P to the power of 5 multiplied by 1 is just P to the power of 5. Anything to the power of 0 is just 1. So that's just P to the power of 5. Okay. Plus 5 times P to the power of 4 times Q to the power of 1. So that's just 5 times P to the power of 4 times Q. You could put the power of 1 in there, but you don't have to. It means the same thing. 5 times P to the power of 4 times Q plus 10 times P cubed times Q squared plus 10 times P squared times Q cubed plus 5 P times Q to the power of 4, and the last part is just Q to the power of 5. Okay, so it's the opposite to where you started. And you should see the sort of mirror image throughout. 10, 10, 5, 5, P, Q. Okay, so we'll call that part A, part B. Using the last 2 terms of the binomial expansion or otherwise, find the probability that Dave is late no more than 1 time in a school week. Okay, so why does it say using the last 2 terms of the binomial expansion or otherwise? Why the last 2 terms, which would be these two? 5 times P times Q to the power of 4 plus Q to the power of 5. So what other information have they given us in the question? They have said the probability of Dave being late for school on any day is 0.1. Let P represent the probability that Dave is late on a given day. So P equals, what do they say, 0.1. So if Dave's punctuality or lateness for the entire school week is summed up within the brackets, P plus Q, whether he's late or not, then the contents of the brackets have to add up to 1. If 0.1 represents when he's late, Q has to represent when he's not late. So Q would equal 1 minus 0.1, which is 0.9. You have to know that. You have to know that 1 accounts for all eventualities. You know, as you think, 100% of the time, is all the time. If you know he's late, if P represents the probability he's going to be late 0.1, and the contents of the bracket is all encompassing, that's everything, you know, late or not being late, Q has to be 1 minus 0.1, which is 0.9. And the question said, using the last two terms of the binomial expansion, so hopefully you should see, if this is our final answer here, it said find the probability that Dave is late no more than one time in a school week. So if he's late no more than one time in a school week, that means that there can't be more than one P. He's not late at all here, okay, but he is late here, okay, but he's just late once. The question was, find the probability that Dave is late no more than one time in a school week. So that's why they just said the last two values, because there is no more than one P here and here. He could be late 0 days, he could be late 1 day, but he can't be late 2, 3, 4 or 5. He's only late 1 day, no more than 1 day, 0 days or 1 day, if we're just looking at the P's, okay? So therefore, if we know the value of P and Q, we can sub it into these two values. So therefore, if you're just using this, it's going to be 5 times P, which is 0.1, times 0.9 to the power of 4 plus 0.9 to the power of 5. You put that all in the calculator, which gives you 0.91854. That's the probability that Dave is late no more than 1 day a week. So part A was probably the bit that took the most time, but I don't think it was that tricky though. As long as you understand Pascal's triangle and you understand descending and ascending powers, that should be okay in the coefficients. That should be okay. The tricky part was just realizing what the probability meant. You have to know that all eventualities are regarded as 100%. As a decimal, that means 1. Okay, so if they've given you one value, you can therefore find the second value. And once you've got P, once you've got Q, you can substitute it in here. Remember, no more than 1 day. Okay, so this is valid because there is no P's at all. There's one P here, so that counts as 1. But the question said no more than 1 day, so you can't have P squared or cubed or to the power 4 or 5. You can't have that. Substitute in P and Q and put it on the calculator. 0.91854. And that's it. For maths tuition, in person or online, you can visit the website at analogos.co.uk. The link is in the description.